Hello, this is Archer Murray, and this is my second video problem presentation for linear algebra. Our first problem is to find the change of basis matrix between these two bases and explain. So when you're dealing with change of basis problems, it can be a good idea to draw a diagram of the bases. So we can see here we have reals squared in basis 1 and reals squared in basis 2, each pointing to real squared in standard basis. However, these arrows are meaningless without a change of basis matrix to identify them. So we can easily get these change of basis matrices by just reading the elements of the vectors in each basis. When we do that, we get 1, 5, 2, 7 for change of basis matrix from B1 to standard, and 0, 3, 4, 3 for the change of basis matrix from B2 to standard. However, notice we want the change of basis matrix from B1 to B2. We can go from B1 to S, but right now we can't go from S to B2. What do? Well, we take the inverse of the change of basis matrix from B2 to S to get the change of basis matrix from S to B2. From here, it's a simple matrix multiplication problem, but first we need to take the inverse of that first matrix. As a reminder of how to take the inverse of a 2 by 2 matrix using the formula, we do 1 over A times D minus B times C, and then and that is a scalar multiplied by the matrix with A and D swapped and B and C negated. When we do all of that, we get an inverse of negative 1/4, 1/4, 1/3, 0, and we multiply that by 1, 5, 2, 7. Pretty sure you know how matrix multiplication works by now, hopefully. And when you do the matrix multiplication, you get your change of basis matrix, which is 1/4, 1/2, 1/3, 5/3. And that's problem 1. Problem 2 asks us to find the determinant of this 4 by 4 matrix. So in order to do that, we need to use Laplace expansion. So here is our cofactor matrix, and we are going to expand based on column 1, taking advantage of all of those zeros in there, which will make computations easier. So first, we're going to do the first element of that column, which is 1. You can see our cofactor is plus, and so we just do 1 times the determinant of the minor, highlighted in yellow, which is 4, 1, negative 3, 0, 3, 1, 1, 2, 0. And then this animation indicates what we would do if the other elements were non-zero, but since they are 0, we can ignore this. So now we need to take the determinant of this 3 by 3 matrix. This time we're going to do Laplace expansion on the third row. So in order to do that, we'll first do the first element of that third row, which is a 1. Its cofactor, as you can see, is a plus, so we just do 1 times the determinant of 1, negative 3, 3, 1. Then we move on to the 2. This time we have a cofactor of minus, so we need to have a minus, not a plus, in this expansion. So we do minus 2 times the determinant of the minor, which is 4, negative 3, 0, 1. Then the last element is a 0, so that doesn't matter. Now, hopefully, we should know how to take the determinant of a 2 by 2 matrix using the formula. We'll start off with the left-hand side, the left matrix. So we have A times D, 1 times 1, minus B times C, negative 3 times 3, to get a determinant of 10. And then for the second matrix, we have 4 times 1 minus negative 3 times 0 for a determinant of 4, which means the determinant of this 4 by 4 matrix is 2. I used Wolfram Alpha to check my answers, Keynote to prepare the slides for this presentation, and Zoom to record video for this presentation. Thanks for watching.